All right. Hi, everybody. Uh, we'll go back and talk about the agenda in a bit, but welcome to the preliminary design review for the Shaman I project. So we're going to start, after introductions, we're going to start talking about the development process. Then we're going to get into some of the technical details, what the system of the Shaman I will be. We'll go into a software review, and then microelectronics review. Then we'll talk about subsystem test plans. But through all this process, we're hoping to get open feedback and discussion, especially instructive, so that we can best develop this project together. First, I want to introduce my team. I'm super stoked about the members of my team, and they all have done great work so far. So first off, my name is Dominic Hoff. I'm the team lead here for the Mechatronics team, and I'm from Boulder, Colorado. Sean?
Hi everyone, I'm Sean Liu. I am located in Boulder, Colorado, and I am a Mechatronics team member, and I'm involved in the microelectronics selection process.
Hi, I'm Rue Brandt. I'm from Centerville, Virginia. And what I've been working on is primarily research for the mesh network and trying to incorporate security objectives into our prototyping.
Hello, everyone. My name is Kyle Psyche, and I'm from Santa Cruz, California. And so far, I've been developing basic firmware tests for the main microcontroller for our project, which is the Teensy.
Yeah, don't shy over that. You're the one hosting our prototype. That's awesome. And Kyle's been running tests and will continue to as we go through this process. Another member is Ilo Dizon. Unfortunately, he could not make it today. He was on a 20-day vacation to Nepal, and he just got back last night. So he wishes he could make it, but he is not able to, unfortunately, but he's been involved in some of the firmware side as well as selecting components in the comparison. Let's start off with what this project is. So our main goal is to develop a sustainable, effective anti-poaching method in jungle environments. Some things that are used currently, of course, the boots on the ground approach. Rangers patrol areas of the Amazon looking for poachers and otherwise malefactors in their environment. There's also an approach using unmanned aerial vehicles, which has a drawback of some of the canopy is so thick that thermal imaging can't get all through, and it's obviously very widespread and sporadic in that surveillance as well. Then, of course, your traditional camera traps that record video based off of sensor movement and send that video off. All these have been effective approaches, but they fail in pretty critical ways that we hope to solve with the Shaman one. For example, there is no strong cellular network inside the Amazon. So communications and sending video or other types of detections like that are pretty short range and do not cover large swaths of area. And of course, minimizing boots on the ground will always be a priority in wildlife conservation efforts.
So the operational concept, this is just a rough slide on what the environment that we're working with, and then the threat picture or the people that would be trying to disrupt our efforts. And so for the environment, obviously we're going to be placing these devices in the jungles of Costa Rica with many trees, and it has a really thick canopy. So a lot of the things that we've been talking about is the radio signals being trapped under the canopy, and then the interference that we're going to get because there are so many trees in the way. And then a lot of the people that would be um, trying to disrupt our efforts would be criminals or poachers trying to profit off of our endangered animals, and then animals, environment, and weather, which we can't control, but would definitely play a factor in what we're trying to do. And then this slide, we are benchmarking. So these are our current products on the market that are reasonably comparable to the Shaman 1 project. These products are the Audio Moth, the Frontier Labs BARLT, Wildlife Acoustics Song Meter Mini Bat, and Zoom H2N Handy Recorder. The metrics that I used to compare these with were the document engineering requirements, the cost of these devices, and then the usability for Shaman 1. We do have a document that lists all of them and the reasons why creating a new device for the Shaman 1 is the correct call.
So let's talk about some of the logistics going into this project. First of all, in order for our method of anti-poacher detection, we are using vocalizations from what are called sentinel species inside the Amazon rainforest and nearby environments. By using this technique, we can actually understand intruders in that environment and be able to make a mesh network of communication that communicates where that location is, so rangers can deal with that situation. So we are going to, in order to communicate this data around the Amazon, we're going to be using what's called a mesh communication network. This network will allow us to get data through the Amazon even without cellular support into a central node that can then send it out of the Amazon. So the biggest risks inside this project that we want to find as fast as possible is the effective range of the mesh communication network. Another part is the audio processing. Can we collect that audio and use it in our model that our other co-teams have been developing in a reasonable frame? And of course, the maintenance and upkeep costs. How often do these modules need that kind of maintenance, and how do we go forward in the future with it? By the time that this project is manufacturer ready, it'll be about a little less than a $1,500 project as an estimation. So in order to approach a project like this, I really want to talk about the development process I've been using and that we will continue to use, because this is not a typical American engineering process. It was first developed by W. Dewing in the 1950s, and I have a mentor named Andrew Goldstein that has helped develop this process further and helped teach it to other companies. Particularly Japanese companies are super interested in a process like this. And when he went overseas to lecture to a small car startup, it ended up being Toyota, which we all know today. But this is the basic principle of this project. We're determining feasibility and maximizing those kind of aspects of the projects that make it good features. So none of this is going to be form factor for the first part of the environment, and we won't have all the answers. But the main goal will be generating those questions and finding answers to them as quickly as possible, where we really find that feasibility in certain features. This will help us determine specs of this project that otherwise are difficult to determine due to a lack of analytical models in a process like this. But again, the process is very much so a cycle where you are generating and iterating throughout this entire process. Then we're going to go into what's called the P1 phase. This system will allow us to integrate these subsystems mostly on the software side and have them run concurrently, find issues in that process This will, of course, have some exceptions to the specifications, but it'll be a big step in doing field testing, especially a little bit more prolonged testing. That will bring us to only in the spring semester, the P2 phase, which will be integrating that system fully, making a professional model and that meets all the requirements. And then we release those then after testing multiple units together, then we can release the Shaman 1 product. Yeah, go ahead.
For our team workflow, we're using Google Drive for all of our writing and documents and Google spreadsheets for graphing and data storage. And then we're using GitHub to share and collaborate on code.
So I really want to nail down what the systems inside the physical package will look like. I don't think you can see my mouse using this method of presentation, but in terms of system sensors for the testing phase, we will need several sensors, including on temperature sensors on the microprocessor and the battery to determine that health, because heat will be a very big problem in this project because there's no form of heat dissipation. We will need to measure the voltage of the battery, and we will also need to be able to test the internal humidity of this capsule, especially in such a humid environment as the Amazon. We need to develop an enclosure that can work in that environment. We, of course, will have the microphone. That's the basis of this project and perhaps the most important sensor. We'll also install motion sensors that can detect in the local environment and turn on the camera. That'll help for security reasons as well as tracking movement and identifying malfactors. We, of course, will have connection ports and power distribution, but a big component in this module will be the mesh communication network, and that is what on-market products do not have, the ability to integrate and communicate information off of a network by bouncing it across each other. So this is the Shaman at P0 setup. Now I want to show you guys what the test schematic will be. You'll see in the bottom are two identical modules. These are the Shaman systems that I just showed you in the previous slide. Using this test setup, we can test mesh communication between those two modules for the P0 stage of this project, as well as we can have a separate microprocessor that basically handles the cellular data virtual monitoring. And for that virtual monitoring, we're running that on a different module just to not eat up that data, because that data and processing usage will be a big testing point in our network. But the virtual monitoring will allow us to do prolonged field tests 1 or 2 days, where we can get that information live about the system sensors, as well as the progress of whatever tests we're doing. All right. Hi, Ron. Welcome in. Feel free to ask questions throughout this process, but we're going to keep moving right along as well. So let's talk about the software aspects of this project and what we selected for the Shaman module.
So, as Dominic was just saying, the importance of virtual monitoring, this will be done by us implementing an API plus database server, and this will help log data gathered by the field test modules. And in the data in the database, we can perform data analysis to ensure the microphone is operating correctly and that the teensy audio capabilities are up to standard.
And something I'll add to this is even without the full audio processing model that our code teams are developing, we can set up a simple like audio detection system, such as Kyle suggested in a previous meeting, like having it start recording when it hears a noise over a certain volume, and then we can start testing that integration early before those models are done.
For our firmware, we decided to go with MicroPython. And so the reasons why we decided to select MicroPython was because of the fast development, high-level syntax, the interactive REPL, which allows for live testing and debugging on the Teensy, and then extensive set of pre-existing libraries, and then the other options that we were thinking of, which may be implemented later on in the Shaman 1 project, would be Platform IO and Zephyr OS.
Yeah, and this is the software that will be uploaded to the modules. So the data that is sent through cables doesn't have to follow this software, but it is one of the best option for the Shaman. And it's also very limited on what softwares run on a microprocessor like the Shaman.
So the mesh network communication, like Dom said earlier, is a really pivotal part of the project. It makes us stand apart from our competitors. And so the rough definition is that each of these devices will be connected directly from device to device. The main reason why we're doing this is for redundancy. And so if one of the devices within the network were to go down, then another node within the network could pick up the slack for that. And so while doing research for this, one of the biggest things that popped up was the LoRa Alliance. And so they standardized the long range wireless communication technology. And so one of these companies that uses LoRa is called Dryad Networks, and they're a wildfire detection device. And so they're actually a company that we're looking to see if we can get mentorship so that we can have a better understanding of how we can connect these devices together. And so, yeah.
Awesome. Before we move on to the microelectronics review, are there questions on the software review we just covered or other inputs?
Yeah, hi, Dom. By the way, you guys are doing a fantastic job with your presentation. Very impressive. Can we go back to the schematics for the testing?
Yes.
Yeah, okay. Actually, yeah, there it is. Okay. So are you guys using you're using 3 different microprocessors for this? Is that
So
how
the Yes, so you can think of the bottom two as the Shaman prototype, and this is a test setup. So in order to run the mesh communication tests, we need 2 Shamans, and then there's other microprocessor that you can see up top. It says Teensy. We chose a smaller and cheaper ESP32. I didn't update the diagram, but that is what handles the processing for the cellular data just because we want to be able to monitor the data and processing on the modules themselves. And so we don't want the cellular module running on that, which is otherwise a one-off part for testing.
So the only difference between the 2 processors, cellular would be on one, and then all the other sensors would be on the other one.
Exactly. The other 2 are our prototypes. That one is for the testing apparatus.
Okay. So, okay, so sorry. So there are 2 microprocessors or just one on an individual unit?
On an individual unit, it will be one microprocessor. It will look like
One.
this.
Okay.
Yeah.
Okay. Oh, I see it now. I see the radio that you would have with
Yes.
that. So the sensors you have would be temperature, battery. What does that mean?
So, once we have developed a housing for this prototype, which isn't quite yet, we will be measuring the temperature inside the microprocessor to see if it overheats, as well as that battery. We will detect the temperature of the battery, making sure that's not overheating because it does generate heat as it is getting used. And understanding the temperature outside is a big part of the setup. And the purpose of all that is we are going to be in one of the hottest environments on Earth, and in direct sunlight, there's no way to dissipate that heat inside a microprocessor, which is generating heat. So being able to monitor the thermal performance of the system might answer a lot of feasibility questions and might mean that we have otherwise some kind of fluids or other system that we need to install in order for it to not overheat.
What are you guys using to cool it off? Is there a fan built into it?
There's no fan. The first step is testing to see if it is an issue.
Gotcha. Okay. Um, and then I guess it's going to be a real big challenge because we do have to enclose everything, waterproof it, but we'll still have to find a way to remove excess heat from the unit itself.
Exactly. If so, there is otherwise, if the housing is tight enough, then heat can be dissipated through natural convection. That is how the heat would be dissipated otherwise. So just testing to see if we need to install some kind of system or change a design in order to incorporate better heat dissipation.
Were you guys able to look at the competition in terms of like what their method is for heat and how do they?
So the other camera systems don't have heat dissipation forms, but it's also because they aren't processing information
Right.
through these modules,
Okay.
which is a big part of this project and why we have to test it.
Is there going to be a built-in GPS as well, or how are you going to record the location?
So these modules should be anchored, and when rangers install a module like this, which is also in the this is the type of system we design in the P2 part of this project.
Okay.
It is like them marking down a GPS location because GPS uses constant power usage otherwise. So we'll avoid the using it if we can. But that's something we'll also explore in later steps of this process.
So there's going to be, I guess, external communication, right? For each unit itself. Are we able to, for example, when they place the unit in the field, can we turn on the GPS at that moment or maybe sync it to the app and the GPS location of the phone app that this is communicating with? So that we could look at other alternatives. But I found phones, like when we were down in Costa Rica, there's still a variation in the GPS location between, let's say, my phone and let's say your phone versus Kyle's out there, right? Even if we're almost in the same exact location, there's still going to be some minor variation in that GPS location. And for any scientific study, that is a critical component of making sure it's consistent. Is it possible for us to add an element that would allow us to have that GPS coordinate early on versus the second version?
So that is a good question. And the really the approach here is if we add a GPS signal to this, there's not a lot of question. GPS can penetrate canopy. We know when we add a system like this to a prototype like this, it will be able to function. And so the biggest step in the P0 process, which is what today is primarily about, is determining feasibility and getting those questions answered as quickly as possible. For what is the big critical things about this project that is going to either cause issues so that in the future, which would otherwise get hidden, or other aspects. So while this is also a totally iterative process, which in a very modular system, so we can add GPS systems in the future and test that in the future. But the biggest question is for the sensors that are already on this, we need to make sure and record those specs for that system. Does that kind of make sense?
Yeah, it does, but I just feel like the GPS is going to be a critical component as an early on that we should integrate. But we can still, go through this process for the fall and look at it as a spring thing. But if you guys can add that to your priority list for next iteration, I think that would be really helpful because if we're planning on going to Costa Rica in May, I want to make sure we've tested all of the different microcontrollers prior to getting down there and have some, test time before even going down to Costa Rica.
Sure. I'll make sure that we can integrate that through in the P1 part of this process as well. So that gets tested well before we go to Costa Rica.
Perfect. Thank you.
Sorry, did you say something, Ron?
Yeah, I was wondering what the concern was of not just using the GPS on the phone via Bluetooth connection when you set it up. For instance, you had some concern about the phone GPS not being sufficient.
Well, I mean, I think if there's a Bluetooth connection to the unit itself, it's different than the way we did it. Everyone had the app and we were slightly in varied locations. And I think the way my GPS was set up was slightly different. I think it was at True North versus, I don't remember if Sarah's was slightly different than mine. So in the field, the team has to coordinate how their GPS is set up. But if we create a Bluetooth connection which communicates and it does take the GPS coordinates from a phone, um, we can we can also probably include something in that script which allows us to make sure that every time it communicates that GPS, it takes the coordinates in the same exact format.
Yeah, I think that's a good way to do it, and it's going to save us power and cost for each sensor. You have to make a Bluetooth connection when you put the sensor in its position anyway. I think what you were saying in differences between phones wasn't the GPS, it was the way in which the navigator part of the phone operates, where it integrates GPS with compass and some kind of dead reckoning system. And the only thing we'll Bluetooth connect is the location data, and that's usually going to be the same for every phone.
Yeah, these are all development questions that we can also start to integrate once we get to that part of the project, where we are integrating those systems together and figure out what an operational model would be for a device like this. But if I may, I'd like to move ahead because we're halfway through our time and let's
Yeah,
hop.
I'm just gonna, Dom, as you're moving to the next screen, I just want to bring up, Jaime, if you can make a note of this GPS, I think we can include that with the app. We already kind of have a GPS already with
Can you
the
hear me?
app. Yeah,
Can you hear me?
yeah.
Yep.
I was gonna add that the phone's GPS is not gonna be as accurate in like the rainforest, for example, because how, like phones get their GPS coordinates from cell towers and like Wi-Fi hotspots, so it's never gonna be like really accurate in places like the rainforest. So that's, I don't know, something that we have to think about. When we're implementing this.
Okay. And that sounds like it'd be an issue whether it's on the module or not. So let's continue this conversation at another time as well, because this is interesting and something we definitely should figure out. So the next step I was going to talk about microelectronics, but we're a little short on time. So I'd rather talk about the testing process in the P0 stage of this process first. So let's hop into it. And remember, a lot of this is about phasing out those technical risks and testing those subsystems together. So Kyle, I'll let you handle this.
I think actually a different team member wrote the
Oh,
P0
was it?
testing
Oh,
plan,
okay.
so I feel bad if I took their credit.
Oh, yes. No, I'm the one who wrote this, so I'll talk about this. The biggest thing is we need to develop tests and metrics for testing that. That way we can move as quickly as possible. We will only have about 15 work days between starting the testing for the P0 and needing to deliver those feasibility results for the P1 stage of this project. So a big one that Kyle has already done because he ordered a teensy and the mic that we'll use for the Shaman Zero P0 is and he set up a test where he is detecting the clarity under disruptive noise, the directionality of those tests as well, the power usage, which we haven't gotten to, and the range relative for those microphones. Um, so another test is, of course, the PIR infrared sensor, which will detect and turn the camera on. We want to make sure it tests correctly in the light and at the dark at the range that it specifies on the package and the power it uses throughout that process and also idle power. The camera functionality test, which we haven't gone over the microelectronics, but recently Sean found an issue with the camera we selected um, for the P0. And so we will need a little bit more time to select that camera and order it for the process. But when we test that, that'll be resulting video quality and the power usage of that camera, both active and passive. The radio frequency antenna functionality test for the mesh communication network will be by far one of the most important ones because it answers a lot of feasibility questions. What kind of range can we get out of it? What kind of data loss are we comparing, especially when sending audio data specifically through that system? Are you getting losing key frequency data that would otherwise identify sentinel species? There's data transfer rate along that line as well. The power usage is, of course, a big thing, and how close can we get it to obstacles, whether it needs to be 3 feet off the ground on a tree or other nearby objects. Teensy to ESP32, that's the testing apparatus. One that's what handles the virtual monitoring, just connecting that, getting it set up so the data transfer happens effectively. So looking for that to just be functional. A max power draw test, developing power draw even without the operational model, we can basically say, okay, at this load, what is the maximum power draw of this system itself? And that will help determine battery life for the battery we selected and the test. Audio packet sending test, finding quality disruption in the audio packets themselves. And how we can send that data, whether we want to send raw audio on the time domain or on the frequency domain, which is a big question that Sammy, I'd also like you to think about as well, is whether you need it to be on the time domain, or if we can package it and send it on the frequency domain and cut off those end frequencies that don't matter and don't apply to the species we're detecting. And then the API connection test, that's setting up the live monitoring. Are there questions or comments on this testing? So that will feed into pretty linearly the P1 tests that we will need to complete. And well, when we approach the P1 stage of this project, we will write out testing plans. These are the um, descriptions and important notes for the basis of those tests once we start integrating systems together. Kyle, do you want to handle this?
Dom, I have one quick
Yeah,
question.
so probably the
Oh, 1
biggest,
second, Kyle. Sorry, what was that, Ron?
Dom, what is the purpose of the PIR sensor again, and where does it fit into the sequence of actions that take place?
So it's just an infrared sensor. So what it does is when it detects movement, it can turn on the camera, and that's what would connect into the camera system.
So we probably want to turn the camera on when the audio picks up one of the species of interest. Is there a dual way to turn the camera on, or does it have to be just the PIR sensor?
Well, we haven't put that together. We are not going to hardwire it into the camera. But also, I hope that the audio we can pick up extends more than the 10 or 15 feet of visual range that we can get out of the camera. Hopefully, the species we're listening for can transmit that data while they are designed to transmit across the Amazon, and we're able to pick that up more than just the immediate 15 feet environment. Does that kind of make
Okay.
sense?
Yeah, I know most wildlife camera traps use PIR sensors. They're good for large mammals that are right in front of the camera, but they're not particular. They don't typically trip from birds.
The primary use of a camera in a system like this that is otherwise has a much larger detection range in audio would be for basically interference. Like if somebody pops up on the trail cam acting like a trail cam, then you can see who that is, or oh, that's Rick, the local ranger, or if that's somebody else, or if there's tampering with the device itself, you can identify what happened where in any identifying information about them.
Okay.
And also, Ron, just on the audio, I understand where you're coming from on that. The issue we're going to have is we might hear a bird or we might hear one of our sentinels, but that doesn't mean they'll show up in the camera. However, and we don't know what distance that species will be at as well. So even if we could trigger the camera to turn on, I'm not exactly sure how helpful or not helpful that could be unless we turn all of them on when it hears a certain sound, but then I feel like we'd be on 24 hours a day or something. So we should think about this because it's a really good thought process. Because audio is going to be critical, important, but I understand Dom's perspective as, this is literally like when someone's going to be in the front of the camera and it's going to trip the camera to turn on. And we probably have to come up with another way of dealing with the audio and detection of what we predict it is.
Yeah, and that is the beautiful thing about the process of development that this is, which it really the core aspect is, Ali, you just named a great question, and how do we set up something to answer that question? That's the biggest part about the cycle in this process. It's a self-feeding process where we can answer those questions in the stage of development where we are. So because that is a more integrated question, that would also build into an operational model, and that's something we can test in the P1 phase. Speaking of, Kyle, I'll let you talk about the P1 testing plan.
So the central purpose for the P1 test is to make the big design decision of whether we're going to have the AI model on a node level or centralized. And the node level means that each module runs the embedded AI locally, and then it transmits results and key metrics across the mesh network. And this is good as it reduces bandwidth and enables faster decentralized decision making. And another possible route we could take is having a centralized computer that does all the processing somewhere else. So each Shaman 1 module would send raw or lightly processed data to the central node, which could be a much more powerful computer to run the AI model on the data. And however, this requires a lot more infrastructure when it comes to the radio, and we'll have to do a lot of testing to see how is the audio quality transmitted over the mesh network. And that'll be seen the specific tests in the next slide. So the first three tests go back and try to answer that big design decision between the node level AI versus centralized AI. And one is the first test is just running the model, or if we can't access the exact model developed by the AI team, maybe we could develop some sort of audio processing program that similar or is on the same level complexity. And can the
Hey,
team see?
Kyle, sorry to cut you off. We could probably, if you want to use audio, we could just use the BirdNet model. We were looking at that for, I think, maybe it was Dawn that created it for the Raspberry Pi. So we could probably use that to test for audio purposes. And I believe there's some visual stuff from Camera Traps that Griffin has worked on as well. So we could provide those models to you guys.
Okay.
That would
Yeah,
be that would be
yeah, that'd be a great thing. I'd also love to hear some more information about it. So I'll make sure to reach out um, to the relevant people and ask them more details so that when we get closer to P1 process, we can have a model that we can integrate and test with.
Now, with this topology, what is the typical spacing between the sensors?
That is what we will test in the P0 phase of this project. What kind of range can we get out of these antennas is the big spec that we are determining experimentally. There's too many factors that go into a thick canopy environment, and it does not follow predictive models well. So being able to test that kind of range first, find out what is reliable, and find our active range at the frequencies we're operating at, and whether we need to move to another frequency or otherwise other aspects.
And just to expand on what Dominic just said, that kind of goes with the outdoor field tests. Is I live in Santa Cruz, and it is pretty different than Costa Rica, of course, but I do live next to a big redwood forest, and setting up the Shaman I modules in the redwood forest with like a lot of foliage in between each module would help simulate what Costa Rica would be like. And so going back to the on-device AI test, we'll implement some sort of model, and we're just going to see how does the teensy hold up under this CPU strain, and what's the output, what's the latency, and what's the power and heat consumption. And next test we do is the mesh network test. Is we'll send audio files between the Shaman I modules, and we'll basically just listen to them and see, is this a good quality audio file, or is it the quality decreasing every time we send it to a node in the Shaman 1 network? And then once we'll do a lot of decision making after those two tests, and that'll help us decide on the how we want to put together the system integration test. And that was just to make sure all the systems are communicating correctly. And the test 3 is all about putting together the actual field test module. And then we'll test that field test module in an inside environment first with calibrated sound inputs. And we would see, oh, I'll create this sound like a bird sound on my phone. Can the field test module pick that up? And that'll help us figure out like the range of the device, the false positive rate, and the signal analysis. And then finally, this will all work towards the outdoor field test, which I talked about earlier in the redwood forest, because there's a nearby bird sanctuary, and we're planning on putting the field module there and detecting what it picks up.
Nice. Any questions on this before we move on to the microelectronics review?
Hey Kyle, I'm so excited for the field tests. Thank you for sharing that, especially with the bird sanctuary. That will be really interesting to see how that works out. Just FYI, now that we're in Arkansas, we do have places we could test out as well. So once you've done the first test and we're like, okay, we've got a model, I would love to then build one here or two and set them up locally as well, especially because if I'm going back to Costa Rica, I really want to make sure I understand I can build it, I can fix it, and deal with the problems in the field if we have to deal with them. So maybe once we get through the field testing and everything looks good, or even during control environments and you're ready to do the outdoor testing, I can order another set for me to start building here and put that in the field so we could kind of test the two environments.
Yeah, that makes sense. So Aaliyah, the Costa Rica trip, is that happening in May? When is that
Yes.
happening?
So
Okay,
we've pushed it to the end of May, and then that gives a lot of the team an opportunity as well to be able to go out since college will be over by that period of time. And it is slightly a different time than the first expedition, which was in March, but it's still not the heavy rainy season, but I expect it's going to be a little bit more wet than it was in March.
gotcha. Yeah, and that is something we can definitely shift testing over to Arkansas when we get to larger phases of this project. Like in spring semester, where we are continuing our P2 phase, that's when we start to integrate everything together. And it won't just be, it'll also be scaling those tests in order to test that mesh communication network that would be building multiple more prototypes to go along with that process. And that is something we can talk about in the future as well, is
Yeah, I
setting
think that,
up longer term field tests.
yeah, and also in March in Arkansas here, it's kind of like their rainy season. So I think it would be perfect timing for us to be able to test it at least for a month, let's say all of April or something, if we can. Test it and kind of get those results, fine tune it first 2 weeks of May. Um, Actually, no, we should probably have everything ready to go by the middle of May, but we can figure that out. I would like to test it under heavy rain conditions.
Yes. And the especially the housing, we haven't I haven't written up the P1 testing that pertains to housing, but we'll likely have to get or use a testing chamber for pressure and in order to simulate those kind of environments where we can control the pressure in order to see how sealed it is and other aspects of that as well. A little bit further into the P1 process.
Just
Um,
FYI on the testing for housing. I know with Audio Moth, one thing I've seen them do is literally use a Ziploc bag. And they've used a Ziploc bag with the little device out in the field. I know for us that's probably going to be problematic because our device is going to be a little bit bigger. It's going to be a little bit more heated. So what the reason I'm bringing this up is we don't have to have the actual housing, let's assume, for this next trip. We can take time to develop that, but we should have a way of still protecting it, even if it's a short-term solution.
Gotcha. That makes sense. All right. With our remaining 9 minutes, unfortunately, we do not have all the time we really need to go over the microelectronics. So I'm going to go quite quickly over the simple components, such as simple sensors, so we can talk about the mic, the radio frequency antenna, a couple of those things. So starting off with the microphone, you're going to have to forgive me on some of these details. Ilo is the person who developed and found this as a best example. This thing is awesome. It's a Adafruit I2S. And I was so surprised when I looked at this. I was like, is this even the mic or is this what connects to the mic? But it absolutely is a mic. Uh, Kyle should have one right now. And he's been using that to test. The audio data that I've listened to is very clear. But there's a few comparisons to other stuff on market. First of all, the biggest thing is it measures between 50 and 15,000 kilohertz, which is a somewhat typical range. There are other options online that could go a little higher, but they have their own drawbacks. This one is fantastic for prototyping. It's also super cheap. This is a little over $6 per microphone. And the biggest criteria for what determines a good microphone is the is the signal to noise ratio. That's the middle column you see, and it has a very good one. It has minimal power consumption, and otherwise it is very effective for prototyping ability with the PDM ports it has. For the P0 and P1 stages of this project, we'll likely go with a single microphone instead of a microphone array. The reason being, but that is again something we're going to test and find the feasibility. Are there issues with doing one microphone versus if we need to set up an array? We need to be able to validate that assumption before we move into an array. Are there any questions on the microphone we're using? All right. So this is the one drawback about that microphone is that it needs approximately 4 volts. So we'll need a buck converter on board that to translate the 5-volt battery into 4 volts for that system. It's just a high efficiency module that is very, very cheap when you get it in quantity. Quickly, this is the power distribution board. This is what we'll use to dish out all the stage power from the battery into the surrounding systems. Sean, actually, first, could you cover the battery, and then I'll let you cover the other
Yeah, for sure.
microelectronics.
Yeah, for sure. So this is going to be our battery. It's going to power our Shaman I prototype. It's 5 volts lithium, 17,600 milliampere hour capacity, which is fairly high, and the highest one I could find for a pretty reasonable price, and it is also rechargeable. Some things we have to consider with the batteries that is the size, because as you get increase the capacity, it's going to be obviously a larger battery. And this one that I have selected is about the size of a deck of cards, so it can fit in your hand. So it's pretty compact.
Yep, exactly. And the reason why we are getting a 17,600 milliamp hour battery is because Sammy, if your model runs out of battery in 2 days with this big of a battery, then there's underlying issues that make the project that would otherwise be a very large issue for the project. So it's basically like this is going to be your maximum option for making this sustainable and be independent for at least weeks at a time.
I had a quick question, Dom, on this. One of the challenges we're going to face, I'm all for rechargeable batteries. There's not power. There's going to be no power. We'll probably have to set up a power station for charging, probably go solar. I still want to develop the rain power thing as well, but we'll have to keep that in mind as we're working through this.
Yeah. Well, the end-to-end operational model would be a ranger having to do routine maintenance on the system, which is long-term. And that would mean bringing out batteries, swapping them, and then moving on to the next battery systems, which hopefully has a lot less in-person involvement than a regular patrols in the same type of area. Sean, who was it that
I did this.
Okay, you got it.
All right, so for the wireless communication module, we picked the Seed Studio WIO SX1262. ILO actually did the selection for this. But the purpose for this is to allow each end node to wirelessly send data to each other. Some of the important descriptions is it offers 22 dBm that transmits power. It's very prototype friendly. Breakout board fits with Target SX1262 chipset, which ensures that power efficiency and compatibility with our chosen micro pi SX126 driver. And then our decision factors were the driver support, power consumption, prototyping form factor, and then performance. And then in conjunction with that, the radio antenna that we selected is very similar. Seed Studio LoRa indoor antenna kit. And so this would just make it so that the connection would be better and then it wouldn't damage the LoRa module in the first place. The radio antenna operates on 915 megahertz frequency, 3 dBi gain on an omnidirectional pattern. A lower gain provides a wider vertical radiation pattern, which is advantageous for testing in various terrains. So like Kyle said, we're going to be testing in Santa Cruz, and we're going to be testing in Arkansas, and we're going to be fielding it in Costa Rica. So having that versatility is very important. And so the things that came into decision factor was radiation pattern and gain, the frequency, the cost of the radio antenna, and then the size and the form factor that is with this radio antenna.
I'll also add here, this is something we might move to a lower frequency, which is lower power draw, which would be effective for a module like this. First, we're going to test it with this one before we order and try that one, just because this has a lot more prototype ability versus the others are a lot more bare bones setting it up. So this will give us a better idea of what we're working with, what kind of power draw, and especially like what are we limited with power draw. So I want to, I know we're about out of time, and I'll be able to stay back and talk through some of these other microelectronics, which is the, and then the bill of materials. But before some people have to go, I'd like to open it up also to the team leads on questions you have in this project. So if you need to leave, you can. Or otherwise, other questions that impact other people. So, Sammy, you and Griffin's teams, I want you to think about like the testing setups that we talked about, because figuring out how to set that up and integrate well with your model will be a lot of the priority of that time. And you have a lot more expertise in that area than I do as well. So just thinking about that, so in the process we can develop testing plans.
Okay. What was the thing you said about the frequency domain earlier? You want,
Yeah. So
is that just spectrograms that you were thinking or something like that?
I don't know what a spectrogram is, but when I do audio processing in my curriculum, basically you can take a raw audio sample and compare it with a graph of another raw audio sample, and you would not be able to tell if they're saying the same word. But by plotting it on the frequency domain, you can actually see spikes at certain frequencies that actually determine that word, and you can tell what word was said. So my understanding is that there's, whether we have a different basis of understanding, but I believe it still works the same way, is what your model will be picking for, those frequencies that make up the call of those birds. And being able to pick up that range, it is a lot more efficient to like send data on the frequency range, because you can cut out ranges. You can be like, this is a minimum and this is a max that pertain to any of the 5 species. And there's some gaps in the middle here that also don't matter. And so we're going to cut that out and then send it, which will be a lot more power efficient and won't use up as much as the communication channel.
Yeah, that's basically what a spectrogram is. It's just like a picture of the frequency. So I think that's basically what all of our models have been. I don't know what Griffin is doing, but at least for my team, that's what we've been working with.
Yeah, so just think about like what's that data you need for your process, and can we get away with compressing it in a way that preserves those fine like frequencies in that some of those birds have in their calls while also not taking up too much data sending time?
Okay.
All right, awesome. Are there, before we continue, are there any other questions? And that goes for my team as well, whether you have teams for others or if you need to leave, you are totally free to do so. Okay, then we'll just keep hopping to it. Let's see. All right, Sean, would you like to talk about this?
Yeah, for sure. So as we mentioned before, Don mentioned before, and something that we're going to be needing to test is our PIR infrared human body motion sensor. It's going to be able to detect humans, animals, and humans in the surroundings of the prototype. This one that I've selected is designed for human detection through its infrared capabilities. This one detects day and night and has a sensing range of 0 to 8 meters with a 120-degree field of vision. Some things that we got to consider with this module is that it has to have night setting capabilities. We want our detection to be day and night. It's got to have a high field of vision and also it has to be really reliable. It's something that we're going to have to test test in the P0 phase to make sure it is reliable.
Awesome. And you can go through some of these smaller sensors pretty quick.
Yeah, so for our temperature sensor, we have to monitor the internal temperature of the Shaman I to ensure ideal operating temperature. This one it's pretty versatile and that has a -55 to 125 degrees Celsius, and this one features a customizable temperature limit alarm, so we're able to be alerted if it goes outside of this ideal operating temperature range. And moving on to the hygrometer is going to be how we monitor the internal pressure and the humidity of the prototype to ensure the preservation of the internal microelectronic parts. Um, this one that I selected has a 0 to 100% relative humidity detection and atmospheric pressure detectability of 300 to 1100 hectopascals. This model has an on-off switch for humidity and pressure, so we're able to achieve power consumption efficiency. Then we're also going to need a voltmeter sensor to monitor the voltage in the prototype. This one that I selected is 0 to 5, detects ranges from 0 to 25 volts, which is within our battery voltage of 5 volts.
And something I'll add real quick about this, when we go through the testing phases, we also want to know what subsystems have what power draw. So this is something we'll use and we'll probe around. And the reason why we want to use this instead of just a voltmeter is for that virtual testing. For that virtual testing, we want to record that data live and send it along with it.
Oh yeah, Ron, to answer your question, we have documentation of all of these modules. I think Dom sent them out.
Yeah, I sent them in an email. It's also something shared with you on Google Docs if you'd like to review that.
Yes. And then moving on to our cellular module. Our cellular module needs to be able to fit SIM card and be able to communicate wirelessly outside the network. This one that I've selected has LTE cellular signal capabilities and fits the SIM card. It is a relatively cheaper option compared to the ones that I researched, and it does accomplish the same task. So I think this is a good option because of that. However, it is one of the more expensive modules on our list, so that's something to consider. And
Yeah.
something also get, oh yeah, go
Oh, go.
ahead.
Just to add on this note, this is a cellular module for that one-off piece for the testing apparatus, where this isn't part of the Shaman prototype. This is part of the apparatus and a one-off part as well. So that also ties into this. I'll let you explain this.
Yes, so with the cellular module, we're also going to need a SIM card. The one that I've selected is a prepaid card for 30 days of service and offers unlimited data. We need a SIM card that has a data plan of high data or unlimited data because if you want to do remote monitoring of our prototype, we need a lot of data to work with. Also, this one, the SIM card is within our cellular network generation, so it works. Um, Another thing is cost, because like if we want to have service for more than 30 days, we would have to keep buying SIM cards. So that's something to consider.
Yeah, and when we looked into some of the subscription-based ones as well, um, we just figured that in like a block of testing, 30 days we'll be able to answer a lot of questions. And whether we want to continue in the future, it might be better than having a continuous subscription that then we have to worry about when to use it, when to cancel it, that type of thing.
Yeah. And then, um, so as we mentioned before, instead of using an additional TC to host the wireless communication of the cellular module, we're going to be using a simpler ESP32 microprocessor, which is a low cost, low power module that gets the job done. Some things we have to consider through the testing phase is that how well it does at hosting this wireless communication because it is very important. And also its compatibility with the other teensy because we gonna need the ESP32 to be able to communicate with the other teensy modules or microprocessors. And then we're also gonna need a micro SD HD card for local storage. So the one that I have chosen is a 32 gig um, and has a read speed of 70 megabytes per second and a write speed of 20 megabytes per second. I think um, I think that 32 gigs will be enough for for like hopefully it will be enough, but we can answer that question later on and see if it's enough.
Hey, Kyle, for what is this for storage for video and audio?
This is something that's built into the Teensy. It has a slot, and basically this is the working memory of it. So it needs some model, but yes, this would be for storing video or code and other aspects.
Yeah, we'll
Yes.
probably definitely need to bump it up because I can't recall if Griffin was here, maybe he would have remembered, but just in the 5 days, oh, we had a lot of collected data, but we could also, but that's also because it was 24 hours of recording as well. So we can revisit storage down the road, but yeah, we could start with something 32 or 64.
Okay.
Yeah,
Yeah.
sure.
That's great. And that's a type of insight that's really valuable as well, Leah, for our process. Is that something we would have known on our own? So that's something we'll revisit in the future. I think you're right. I think this is fine for this stage of the testing, especially since it's going to be a little bit of time before we get the camera as well. So yeah, actually, Sean, this is something I found. This is the ammeter, let me just explain this for a second, because this is also going to be something we use to get the live power draw of the system. And it's super cheap, only $1. Only problem, Sean, I found when I was making the bill of materials is that this is $50 for shipping and will take a month and a half to get here. So we'll also hold off on this as well. But
Okay.
otherwise, this is something that might be on the final system as well, because it's so cheap, and in bulk, it's very, very cheap. Um, this is a camera that we also aren't going to be able to, oh, or this is a functional a camera that could work. I'll let you explain.
So yeah, this is the camera module I've been looking at that works with the TNC. Some problems I've been running into is finding a camera module that is able to like hook up to the TNC effectively. This one that I've selected hooks up directly, so it is a pretty simple connection. And it does check all of our boxes. It has infrared, night, thermal imaging capabilities, and it does have a really nice 110-degree field of vision. However, this module is the most expensive module on our list, so that is something we should consider and weigh the pros and cons of.
Yeah,
Some
so
things. Go ahead.
sorry, Aaliyah, this is why we're holding out there on the camera for now. Basically, the issue with the camera right now is that there isn't a built-in accepted like a camera port like DVI into the Teensy. So there needs to be an intermediary step, and that's something we haven't identified yet. It's definitely possible. We just haven't found out how, so we won't need, so that's why I'm saying let's hold off on this $57 camera, not including shipping. Because the other ones we were looking at were like $7 for the same functionality, but of course needs that intermediary step as well. Does that kind of make sense?
Yeah, definitely. And I think I know for the drones, we've worked with so many cameras and so many different ways to connect it. So we could definitely look into details and give you guys some different options that we've worked with.
All right, perfect. Yeah, Sean, I saw the link you sent for the ammeter. That'll probably work. After this call, I'm gonna just quickly review it as well. But yeah, anything else?
I think
I was
Ron has.
Yeah, I was going to ask him if my understanding of the little Tinsy processor that has a USB interface. Have you looked into just using a USB cam?
USB camera? No. That is, I'm writing down notes. But also that would mean that when we connect to it, we wouldn't be able, when we connect to it via a computer, we would have to unplug that camera, which would be unfortunate, but that is definitely possible. A USB-C camera output is definitely something we'll take a look into.
Or if you had to, you could just put in a tiny little, USB hub with multiple connections.
Uh, I see what you mean. I'd have to look into that. There might be some data transfer issues, but that is definitely something, that's a good idea. Great insight, and I'll look into it before Friday
Yeah,
as
that's a good
well.
point.
Yeah, Ian? Hold on, we can't hear you.
All right. Thanks. It says it has thermal imaging. What is the resolution of the thermal versus the actual regular camera? Because I thought those are usually like at this price, like 32 by 24 pixels.
Um, I believe it's 30 FPS. that is the resolution.
Well,
But I would.
yeah, I'm not sure. It's 648 by 488. And but either way, this camera that we're looking at isn't a good representation of what we'd be buying anyways, because we'll be looking at another camera for that resolution as well.
Okay,
So,
thanks.
so you're talking about the thermal resolution, or?
Yeah. So I don't think I've ever seen a camera at this size and price point that offers 640 by 480 thermal imaging. It's usually like tiny.
Gotcha. Okay, cool. Ron, do you have another question? I think you might have left your hand up. Either that or we can't hear you. Okay. So that brings us, I believe, to the bill of materials. So let's talk about this a little bit. So our proposal for the testing apparatus we have set up for everything we need to build two Shaman modules, essentially, as well as the third module, which handles the virtual monitoring. That entire system for the next 3 months would cost a total of $380 about. That doesn't totally include shipping. Aaliyah, I also included on here, I found everything on Amazon if possible, because it's a more realistic price than some of the stuff when you ship it before tariffs and shipping. So this is more realistic to the final cost. There's still a lot of much less expensive components that would go through AliExpress, and buying in bulk through AliExpress is the cheapest way to do it. But it'd probably add about $40 or $50 as an estimate, depending on where it needs to go, which I haven't tried yet. But this brings the approximate cost per module to be about $130. Keep in mind that which I am personally very happy about for a prototype, because it only gets cheaper when you start doing these in mass, especially because some of these components that I found on Amazon are actually half the price, such as the breakout board I mentioned was about the microphone breakout board was $6, but on Amazon it's 12. But if you get it in bulk, then you can ship it and have it at $6 and save on that kind of cost. So this kind of functionality at $130, I think, is pretty impressive. But also for the next 3 months, this is what our costs would be.
This looks great. This does not include the camera, or does this include the camera?
This does not include the camera. I can follow you up with you with the camera as well.
We could do that, yeah. Because we'll probably need that. So this is everything except for the camera, or is it missing anything else?
Let me double check that for you. I'm just looking at our other chart.
Yeah, this would really we would be so competitive against anybody that's out there, right? Like you said, if we could get this even cheaper, oh my gosh, we get this worldwide.
And Rue kind of talked about some of the benchmarking, and when comparing it, I think the most expensive competitive product was $1,100, and it has the functionality of this device without the mesh communication network.
Yeah, that's huge.
Yeah,
you guys did a great job. I mean, the presentation was phenomenal, and it's like you've learned so much in the last 1 month. It's incredible.
Thank you very much. That concludes our part of the conversation. Everybody take a bow. Not you, Sean. You don't have your camera on.
My camera don't work.
Bravo. Bravo. So exciting. You guys were fabulous. Absolutely amazing. You should be really proud of yourselves. This is like next level stuff that you guys put together and presented today. So not stuff you're going to do in school. So definitely this is huge in terms of life experiences that you're getting. So Dominic, thank you for leading the team. You've been an amazing team lead, and I think you've got some amazing members in your team, and that's the reason why you guys made it so far in such a short period of time.
Yes, I'm super impressed with my team. Everybody has been just astounding. Ilo off the bat was giving me 4-page reports on the new component he found and how it compares to others. Rue has been involved in so many aspects, including what's currently going on with Dryad, and just so out there in gathering a lot of that information. Sean has been awesome. Sean, you have a background in biochem and mathematics as your major, and he's selected most of the microelectronics for this project, which has been just fantastic. He's put in a lot of work, and so has everybody on my team. And don't forget Kyle, who's took the initiative even before our PDR to get some of those components and start just messing with the microphone, seeing what works, seeing what doesn't, really getting hands-on. So this team has been great. I'd also like to open up before we end to questions or comments or other aspects. This is where I'd love to get your guys' input.
I did read the document you sent me, so it was really helpful as you guys were going through in your thought process. I loved how you explained in that document like why you chose the components as well. That was really helpful. So I will have Ron look through all the micro components that you've listed, and he might have some suggestions for you in terms of other options that might work better, perhaps, especially with the camera, like we're talking about. So I'll let him kind of handle that with you. And then once you guys are okay with all the components, we'll get them, we'll purchase them and get them on their way to Kyle.
Sure, that sounds great. And Ron, something I'm totally open to a dialogue, especially if you have questions or comments about some of the things we've chosen. It's like, well, why this? Like I can, that's part of the purpose of this meeting as well, which is, let's see, like talking about some of these components, such as the LoRa module as well, and like talking about why we selected this and the reason behind it. And if you have any questions right now as well, I'd love to hear them. All right. Thanks, Sammy. Thank you for coming. I appreciate it.
Yeah, thanks, Tom. I think we're kind of out of time here, but for me, it's going to be best if we can get your package into a Discord area where we can chat and kind of evolve a little bit. I know you guys have been using Google Drive for most everything. Some other teams have been using Discord, some have been using other tools, but is there a way you can open do you already have a Discord channel where you can put all this information?
Yeah, in the Shaman Discord, I'll put all of this inside the microelectronics. Specifically, I'll put the links to the spreadsheets and everything, and that should connect you. Also submit the folder that everything belongs in as well.
Great, thank you.
Awesome. And then that's where we can have our back and forth as well. And if we need to set up short calls to answer some of those questions, that's totally fine, because the biggest thing is it's going to take so long to order some of these components. Some of them might be 2.5 weeks, that the earliest that we can order it, the better. So that's why I'm going to try to be available, try to be able to answer your questions so we can go through this and then select those.
Hey, Dominic, I think that the email that you sent with the list, didn't that have a link to all the components, or it just has a list of the components? I forgot.
The document is without a couple. It's about without a couple of components. I'll send you the sheet, Ron, which
Yeah,
has all the components and the bill
yeah.
of
Do you have
materials.
it? Is it in an Excel spreadsheet?
Yeah, it's Google Sheets.
Okay. Yeah, Google Sheets is perfect. Yeah, that'd be great. And then if you could share that with Ron as well, he's pretty good about finding stuff, shipping faster. I'm surprised we're getting people coming down the driveway, which is like a mile long plus uphill with UPS and Amazon deliveries, which we didn't even think we were going to be able to get here. So I'm sure Ron will find a way to get this stuff to you guys sooner.
Gotcha. That's awesome. Sean, I think he left already, but thank you so much. He's great and he needs to leave. So with that, unless anybody has other questions, I think that about concludes our time as well. So thank you everybody so much for joining.
Thank you so much, Dom
Thank
and
you all. Oh, sorry.
team for such a fabulous presentation. This was amazing. Sorry, Clark, didn't mean to cut you off.
Thank you. You know the Shaman team setting the bar high for everybody to
Yes,
follow.
And Dom,
absolutely.
are you gonna continue to work with Aaron on this?
Yes, I'll also, I spoke to him before the PDR, or a week before, I should say, and I'll also follow up with him. I'll also send him some of the materials. When I talked with him, he was like, the steps you're doing, the P0, P1, P2 steps, those are just great. He loves those. And he gave me some ideas what to develop, like an operational concept and a threat picture for the P1 process. And that's something we'll present later down the line as well. So I'll keep him in the loop so he can give that input about the project.
He's also a great connection point into the Naval Research Laboratory, where they have people working on all these components as well. And I think it'd be very helpful you to kind of build your network of experts that are working in the industry.
Yeah, totally. I agree. I'll reach out to him sometime this week or next week. All right, that's all the time I have though. So thank you everybody, and have a good rest of your evening.
Thank you, guys.
Yeah, thank you.
Great job. Have a good night.
Thanks, everyone. Have a good night.
Bye.
Thank you. Bye.